Hi, I'm Benny D, and in this video we're going to be looking at finding the sample size for binomial distribution. Okay, so you might be at a carnival or a fair or something like that, and you've worked out the probability of winning a prize is some amount. Okay, you really want to win a prize. Okay, so you want to have a high probability of winning at least one prize. Okay, what you want to be able to do is find out how many attempts you need to make, okay, to ensure that you have a certain probability of winning a prize. Okay, so for some of these we can do it by hand, okay, and some we'll need to do using our technology, using our calculators. Okay, so I'll go through how we do one by hand, okay, and then talk about the types of ones that you'll need your calculator for. Okay, so we've got an example here. So probability of winning a prize is 0.3. We want to know how many attempts needed to be made. How many attempts need to be made, to ensure a probability of winning at least one prize is 0.95. Okay, so we've got a reasonably good chance of winning a prize, okay, and we want to be very confident that we're going to win at least one prize. How do we go about this to find out how many attempts? Okay, so what we need to think about is the probability that x is greater than or equal to 1. Okay, so that's our winning at least one thing, and we want that probability to be greater than 0.95. Okay, so the easiest way to think about this, okay, is going, well, the alternative is not winning a prize. So we're going to do the probability, 1 minus the probability that x equals 0, so not winning a prize. Okay, and that's still going to be a 0.95. Okay, rearranging this, we can say, well, the probability of not winning a prize, then you want that to be less than 0.05. Same way of saying this thing. So the probability of winning at least one prize being greater than 0.95 is the same as saying the probability of not winning a prize is less than 0.5. Okay, now, if we actually set up our equation here, so we're going to be talking n choose 0, p to the 0, 1 minus p to the n is less than 0.05. Okay, now n choose 0 is 1. Okay, p to the power of 0 is 1. 1 minus p, now in our case, p is 0.3. Okay, so we're going to get 0.7 to the power n is less than 0.05. So you can see the first two parts of our equation just drop out as 1. So now we've got to solve the 0.7 to the power n is less than 0.05, and we can actually do that via logs. And say log to the base e of 0.7 to the power n is less than log to the base e of 0.05. We'll bring our n down the front. Okay, so it's n times log to the base e of 0.7 less than log to the base e of 0.05. Now I'm going to divide by log to the base e of 0.7. Now, because this is less than 1, okay, this number here is actually going to be a negative, so actually divided by a negative, which means we've got to change the sign of it, the direction of our inequality sign. So log to the base e of 0.05 over log to the base e of 0.07. Okay, when we actually do that, we find that n is greater than 8.399. Okay, so if you attempted here to round down, okay, but no, we've got to be greater than this. So if we round down, our probability won't be above this. So these type of questions you have to round up. So that means that you've got to play 9 games. Okay, so we'd have to play 9 games to ensure our probability of winning at least one prize is 0.95. Okay, so this worked, okay, because we were looking at finding the probability of winning at least one prize. Okay. If, though, we're talking about something like winning at least 2 prizes, okay, so now this is 2. The problem that we've got is we've got 1 minus the probability that x equals 0 minus the probability that x equals 1. And now as soon as we go x equals 1, this isn't going to just drop out. Okay, you're not going to have this drop out, okay, because this n choose 1 is going to be n. We're going to have a we're going to have a value here now, okay, and we've got a value here. So we end up needing to set up an equation and just getting our calculator to solve it. Okay, so you might be using the TO Inspire, you might be using the Casio, whatever textbook you're using is going to go through and show you that process of solving that on your calculator if you're not sure how to. So hopefully that's enough to get you through the questions on this section.